Hello, my name is Drake Pocsatko, and I am a Cloud Senior Consultant with Slalom Columbus focused on AWS. Today I'll be presenting how to deploy a Python API to the cloud fast. My contact info is currently on screen. Feel free to connect with me after the presentation. Today we will be covering a brief introduction to what is cloud, and then covering what is serverless and the AWS Serverless Application Model, followed by what is AWS Lambda and AWS API Gateway, and we'll wrap things up with a live demo. So let's start off with what is cloud. Amazon Web Services defines cloud as the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases on an as-needed basis from a cloud provider like AWS. Essentially, what this means is that the cloud is just using someone else's computer over the internet. Some example cloud providers are Amazon Web Services, also known as AWS, Microsoft Azure, and Google Cloud Platform, also known as GCP. Now let's talk about what is serverless. Serverless computing is running code or applications without having to provision and maintain the underlying infrastructure. The servers and infrastructure still exist, but they are obfuscated from the developer. This obfuscation allows for developers to focus on the business logic and spend less time thinking about the plumbing necessary to run their applications. Some example serverless services are AWS Lambda, AWS API Gateway, both of which we'll cover more later, AWS S3, Azure Functions, Azure Cosmos DB, Google Cloud Functions, and GCP Firestore. To enable easier serverless development, AWS provides the AWS Serverless Application Model, also known as SAM. SAM is an open-source infrastructure as code framework for building and deploying serverless applications. The IAC component of SAM is built on top of AWS CloudFormation, which is AWS's primary IAC tool. SAM also provides a local execution environment for building, testing, and debugging of serverless applications. Finally, SAM can be integrated into CI/CD deployment pipelines for automated deployments directly to the cloud. This link covers all the information covered here and will help you get started with SAM beyond what is covered today. Now let's talk about two highly used serverless products, AWS Lambda and AWS API Gateway. AWS Lambda is a function as a service, or FaaS tool. This provides the ability to run code without provisioning or managing infrastructure, where developers only need to upload a zip file or a container image to run their code. AWS API Gateway is, shockingly, a serverless API gateway tool that is fully managed and makes it easy for developers to create, publish, maintain, monitor, and secure APIs at any scale. API gateways in general can be a very in-depth topic, and I recommend anybody who is interested to learn about them beyond the cloud offerings. Both Azure and GCP have comparable services to Lambda and API Gateway, so be sure to investigate those as well before deciding which cloud provider is best for you. Now it's time for the demo. We will be initializing our new SAM project, testing it locally, deploying it to AWS, and then testing it in the cloud after deployment. To follow the demo for yourself, you will need the following things: an AWS account with your credentials set up, the AWS SAM CLI installed, Docker Desktop installed, and Python 3.7 or greater. Amazon no longer supports Python 3.6 or lower versions for Lambda functions. Today we'll be using Python 3.9. We'll start by running the SAM init command to get the files we need to start a SAM project. We'll start with a quick start template, a zip artifact, and Python 3.9. And we'll name our sample app PyOhio 2022 demo. Now that we have the files pulled down from GitHub, let's see what we have. Now let's take a look at what SAM provides for a new application. Starting from the bottom, we'll look at the template.yaml file first. This is where the SAM infrastructure as code will live. The most important part for this demo is this hello world function. This is where we'll define both the Lambda function and the API gateway. In the property section, you can see that we're passing in the location of the code and the specific location of the function, as well as the runtime and the architecture for the Lambda. Here in the events section is where we're defining our API. SAM is able to convert this into an API gateway on deployment, where all of this code will be rendered into traditional AWS CloudFormation code. Next, we've got our README and gitignore, which come with every new SAM initialization, a test folder for our unit tests, and our actual business logic will live in this app.py file within the Hello World folder. You can rename all of these folders and files as you like. This is just what it looks like out of the box. In app.py, it'll specify whatever parameters we have, and for now, we're just returning a simple 200 with the message Hello World. We also have this events folder with an events.json that will allow us to test the Lambda locally using the SAM interface. The next thing we'll do is actually invoke our Lambda using SAM. First, we'll need to get into the directory, and then next, we will go ahead and invoke that using the events file that we were given as part of the initialization. You'll see some words just from SAM telling you what's happening before we finally see what's actually happening with our request, where we get our status code 200 and our hello world return. This worked out great, but now let's see it work dynamically. We'll call SAM local start API, and you'll see again, we'll get some logs from SAM telling us what's happening. I'm going to make a new session, and then we're going to go ahead and curl that at that hello world endpoint that we made. You can see up top more logs for what's happening when we invoke the API, but down here we get our message, hello world. Everything seems to be working in order, so now we can actually do our deployment. First thing I'm going to do is cancel our local invocations. Next, we're going to just run SAM deploy, and for this demo, I'll be running it with the guided command. So the first thing we'll need to do is provide it a stack name for CloudFormation. We'll call it PyOhio 22 demo. I already have my region set up in my config file. We do want to confirm changes before deployment. We do need SAM to be able to create its own IAM role to have the permissions to create what it needs to create. We do not want to disable rollback because this way, if something fails, we'll still have the working resources. And for this sake, we are okay with having authorization not yet defined, since this is just a sample application. It does not really matter if you save your arguments to a config file. This will just make it easier for future deployments. So now you'll see that it's going to start whipping up the actual CloudFormation. I'll close my lower session just so we've got a better view. So it's making a change set, which is what AWS calls anything you do when you change something in CloudFormation, including creating things net new. And you can see all the new resources that we're going to get. We'll get our Lambda permissions that allows it to actually be invoked. We've got our IAM role that allows our Lambda to interact with other resources should we have any others. We've got the actual Lambda function, the API itself down here, a stage for the API, and the actual deployment that will allow us to hit it over the internet. And we're going to confirm deploying these changes. So as SAM deploys these resources, we'll see on this screen here, all of the resources show up as they are being in progress and finalized in the cloud. This can take up to a couple of minutes. Normally it doesn't take all that long, especially for these sample applications. They're starting to complete a little bit quicker now that they're actually being finished. You see that we've already got the API, the function, and the role completed. Now our deployment is done, with the stage being the final thing that happens. SAM is smart enough to know the order in which these things need to be created, and similarly, once we delete things later, it'll know the order in which to delete things. The last thing we'll need to do is just clean up our resources. We can do that as easily as SAM delete. Yes. Yes. So it's going to go ahead and go through with deleting that stack. Everything will be cleaned up, and this is very important if you don't want to run up any charges that you're not expecting. Finally, here are some additional resources if you would like to keep looking into serverless, SAM, and other cloud providers' solutions for serverless. Thank you, and have a great rest of your PyOhio 2022.